Go Language Programming, Chapter 6, Unit 7. In this unit, we will cover handling pointers with reflection and accessing private fields with reflection. So let's first go over handling pointers with reflection. If the interface value is a pointer, use the function in the reflection indirect to convert a pointer value into a actual value. Okay, so by using this or calling this indirect function from this package reflect, then you can convert a pointer value into actual what the value of that pointer is. Okay, so let's look at how it's done in this example 6-22. And so we have a package main, and then we import the FMT package and reflect package, and then within this example we have a struct called a person with one field in it. Okay, and that field is of type string, and then we have a print foo function. Okay, basically in this case this or the method foo is a method. Okay, because it is taking the receiver, and the receiver is passed as a pointer. Okay, so within the body we are accessing this because it is attached. This method print foo is attached to the person struct. We are accessing the field from within the person, by using the this pointer variable, so just remember, as we discussed before, that Go language does not require us to do the dereferencing. We can just use a dot operator to access, even though it's a pointer. EMP is a pointer type. We can just access the a field from the person struct by using a dot operator. And within the main, what we are doing is initializing the person name. Okay, and and then getting the address where the memory was allocated and initializing it to this pointer, because this will become the pointer. EMP is a pointer type. Okay, and then using so return the reflection value of a pointer, the address. So then we are using, since it's a pointer type, we are using the indirect. Okay, like this bullet is saying, so we are using indirect and getting the value of this this whatever the value of this pointer is, and giving it to the indirect, so it will convert a pointer into actual value. Okay, that's why we are doing this. So in line number 23, we are saying that, okay, I want to get the name of the field. Okay, name of the field name. What is the name? So I have to go through, and since I know the value, because of this reflect package, so I'm using value dot type dot field. So, and then I'm giving the field as because it is only there is only one field in here, so this starts with a zeroth. So basically I will get the name of that field, you know. So that's what it is going to print. Okay, it's a field name, which is nothing but a name. Okay. This, by the way, this name is not the same as this name. Okay, don't get confused. This name is coming from the reflect package. This name. Okay, and this name, which is at line number 8, is the part of this struct person. So they are not the same thing. And then 24, we are saying, okay, I want to get the value. So, I will get the value, whatever the value that is holding, I will, get the printout. So it will print this name right here, my name. And then I'm saying that, okay, the instant data, instant data, whatever the data that it has. So it is saying right here, by putting the n%, is saying that it's a pointer type data, so it is just displaying the data name, whatever the name of the data is. So basically, that's how you can handle the pointers by using the reflect indirect. Okay, or that's how you can convert the pointers to the values. So let's look at this last example that will allow us to be able to access the private fields by using reflection or reflect package. So with reflection, it's possible to read but not write. Okay, just only you can read unexported variable, which means the private unexported fields or the private fields of the struct. Okay, so that is in a different package or in the, you know, so basically, whenever you feel that you need to be able to know, the private fields in the other package, you can use a reflect package. So access unexported field length, len, okay, which is in the list struct. List struct is a container, in Go language. So basically, it will allow you to create a linked list. So this example, what we are going to be able to do is, because in this list struct, this is the this is the code that is in the list package. That list is a standard library package, under the container. So it's a sub package under the container. Container is a package, and then there is a sub package list. And this is basically the struct within this package, the list struct. And in here, as you can see, the this length that I want to be able to read is a lowercase. The first character is lowercase, so that means it's unexported. But I want to be able to read only, so I can use a reflect package to do that. Okay, and this following code will tell us how to read it. So in example 6-23, basically we have we import this container list, okay, from the standard Go library, and we have a FMT package, and we have a reflect package. Now, this list, which will allow us to create the linked list, has a new function, which basically is, is going to do is to create a new list, okay, for us. And then it also has um, uh, a push front function. So push front function, basically what it does, it creates a node for the linked list. So in this case, we are creating a three nodes, one, two, and three. Three nodes with the each node will have these strings: apple, banana, and orange. Okay, so we created a linked list by using a standard, linked list that is provided by the list package, which is the sub package of container. So now this is the linked list right here, okay, and this package list takes care of all whole list, okay. But what we are interested in is to be able to access the length that is within this list package, so length is the field name that will keep how many nodes are created. That's what the information that it will keep. Okay, in my case right here there will be three nodes. Okay, so that's why it should print three. So now I use the reflect package right here to make a call to value of L. So I'm getting the value of L, and then from the value of L I'm calling the element. Okay, and then from that element will get me to a field by name. So field by name I give in this case len. If I would have given root, then I would have got this one, the number of elements. So that's what I would have got. But I needed to get the size of this linked list, so I just give a length. So it is reading this list struck, and then the field name len, and that's what I will have. So this guy fv holds the field value. So I'm basically getting the field value and reading it as an int. So that's what it is going to print. And right here it is printing number 3. If I try to set the value by using this reflect package, the set function, I will get, that's an illegal operation. I cannot set. If I would be working with the with my own code, then again, I would not be able to write it unless it's exported. So then I can use, if it is an exported, then I can use this set function from reflect, and then I will be able to write whatever the value that I need to write. Okay, so this basically concludes the chapter number 6, and we will be moving on to chapter number 7 soon.